Parts of the periodic table. You do not have to memorize the elements or the symbols or the atomic numbers of the periodic table, but you need to understand how the periodic table is organized. For any periodic table, anything that is in red is in a gas state. Anything that is blue is in the liquid state. Anything that is black is a solid state. The discovery of the periodic table was credited to Dmitri Mendeleev. His periodic table were organized in periods which go horizontal or in rows. There are currently 7 rows, and they're arranged in increasing atomic number. In the vertical columns, they were known as groups or families. There are 18 currently, and they are arranged by similar chemical properties. The periodic table is also divided by the zigzag line. The pink zigzag line shows the separation of the metals, nonmetals, and metalloids. Metals are located on the left of the zigzag line. They are malleable. Malleable means pounded into thin sheets, like pots and pans. Ductile means to be pulled in thin wire, just like copper wiring. They are good conductors of heat and electricity because they have loose valence electrons. They have luster, which means they are shiny, and since they tend to lose electrons, they are cations. Metalloids, or semi-metals, are located along the zigzag line. They contain properties of both metal and nonmetal. The most common metalloids are boron, silicon, germanium, arsenic, antimony, beryllium, and polonium. Nonmetals are located on the right of the zigzag line. They are brittle, hard, or soft. They are poor conductors of heat and electricity, and they are anions because they tend to take in electrons. Group 1 is known as the Alkali Family. Remember, groups go up and down. They are vertical. They all have similar properties except for hydrogen. So the Alkali family is lithium, sodium, potassium, rubidium, cesium, and francium. Hydrogen is in the family because it has 1 valence electron. Reactivity increases down the group. That tells you that francium is the most reactive element in the family. They are stored in oils because they are highly reactive. They react with water to form base. They have 1 valence electrons. Remember, valence electrons are electrons in the outside shell or energy level. Since they have 1 valence electron, they tend to give it away, and so they form a positive cation of +1 or 1 plus. Group 2 or 2A is known as the alkaline metals. They have similar properties as group 1, but they are less reactive. They are all metallic elements. They have 2 valence electrons. Since it's easier to get rid of the 2, they form a +2 or 2 plus cation. The next family is the boron family. It is group 13, column 13, or in the old textbook, it is known as 3A. They are all soft except for boron. They all contain 3 valence electrons. Boron is a metalloid. It has properties of both a metal and a nonmetal. The remainder are all metals. Please note that aluminum is a metal, even though it is along the zigzag line. Carbon family is group 4A or 14. They become more metallic as you go down the group. They have 4 valence electrons, so they can gain or lose 4 electrons. So they tend to be 4 plus or 4 minus. So they could be a cation or an anion, depending on what they combine with. Carbon is a nonmetal, silicon and germanium are metalloids, and the remainders are metals. The next group is known as the nitrogen family. It is group 5A or 15. All solids except for nitrogen, which is a gas. They range in properties and they have 5 valence electrons. Since they have 5 valence electrons, they tend to gain or receive 3 electrons and become a charge of 3 minus and is an anion. Nitrogen, phosphorus are nonmetals. Arsenic and antimony are metalloids, and the last 2 are metals. Oxygen family is group 6A or 16. Properties vary. They have 6 valence electrons, so they tend to gain 2 electrons and become a charge of 2 minus, and again, an anion. The nonmetals are oxygen, sulfur, and selenium. Selenium is usually a metalloid, but for this class, you can learn it as a nonmetal. Beryllium and polonium are metalloids, and the last one, livermorium, is a metal. Halogen is group 7A or 17. The definition of halogen means salt former. A salt former is one that has a metal, usually from group 1 or 2, plus a nonmetal that's a halide, which is like fluoride, chloride, bromide, iodide. These are all nonmetals. Unlike group 1, their reactivity increases going up the group. So the most reactive element here is fluorine. Fluorine, chlorine, bromine, and iodine are nonmetals, and the remaining 2 are metalloids. They have 7 valence electrons. Since they have 7 valence electrons, they like to gain 1 electron and become a charge of -1 or 1 minus. And so they are all anions. Noble gases are group 8A or 18. They are known as noble, inert, or rare. When they were first discovered, they were non-reactive, except for argon and xenon, and currently ogansson. They are all nonmetals. They have 8 valence electrons, except for helium. Helium only has 2. So therefore, they have no charge. Remember, all elements want to have a full outer valence electron shell. They follow the octet rule. For metals, it's easier for them to get rid of the valence electrons to fulfill the octet rule, while for nonmetals, it's easier to gain electrons to fulfill the octet rule. This is why metals are cations or positive charge, and nonmetals are anions negatively charged. Transition metals are groups 1 through 10b in the old periodic table, or 3 to 12 in the new periodic table. They're pretty much all metals, and they are called transition metals because they have variable charges, which means they can have more than 1 charge. Example of that is iron. Iron could have a charge of 2 plus or 3 plus, depending on what it's combining with. However, there are some exceptions to the rules in which you have to remember. Most of the elements will have more than 1 charge, but there are some exceptions. These you need to memorize. Zinc has a charge of 2 plus, silver has a charge of 1, and cadmium has a charge of 2 plus. It is best that you write it on your periodic table so you know it. There is another set of exceptions, which I mentioned earlier. Tin and lead, even though they are in the carbon family, will behave like transition metals. They tend to be 2 plus or 4 plus in charge. The rare earth family are the two rows that are pulled out in the periodic table. The top one is known as the lanthanide series, and it has atomic numbers 57 through 71. The actinide series is the lower row, and it is 89 to 103. They all have metallic properties, and their use are very important in technology. Hydrogen is a loner. It is found in group 1, but not an alkali metal. It is there because it has one valence electrons like the rest of the group. It is a diatomic, so in nature it never occurs alone. It will always be an H2 when it's by itself. In addition, it behaves like a metal when it combines with nonmetals and behaves like a nonmetal when it combines with metals.